Hi, my name is Elijah Lin. I'm a computer science major at WSU Pullman, and my project was on understanding relationships between mapping tools. For this internship, I was lucky to be working under the direction of Bernadita Salato and Juan Murillo. The goal of my project was to analyze the correlation between two mapping tools in order to better understand the relationships between soil and vegetation. Crop loss is a big issue in the industry, and we hope that the information we can get can help growers optimize crop management. So vegetation indexes were one of the mapping tools I used in this project. Essentially, they are these numerical values that represent certain vegetation characteristics of the area, such as the health of the crop or crop vigor. Typically, they're obtained through aerial imagery of fields, which in our case, we got them through drone imagery thanks to the CPAS group. Here on the left, we have the NDVI, which is by far the most popular vegetation index. NDVI is a good indicator of greenness and has a strong correlation with biomass, which is indicative of growth. NDRE on the right here is used to measure the chlorophyll content within plants, and can be better than NDVI in some cases where the vegetation is more dense because of its ability to measure density past the canopy cover. However, in areas with lower chlorophyll content, NDVI would be the better option. Soil Optics is this soil testing company based in Canada that provides this service where they essentially drive through the orchard in this four-wheeler ATV type vehicle with a gamma ray sensor attached. Then they provide us with these data points all throughout the orchard with information about the macronutrients, micronutrients, and physical soil properties. So my initial approach was to conduct single spot correlations between these four different sites where soil optics data proved to be significantly different, and to look for correlations there, with the hope that their correlations would also be significantly different to help prove some sort of relationship between the two sets of data. As you can see on the right, these images show the four different sites, and you can see that these four different sites have fairly different soil texture as well as different levels of calcium. However, we realized that this method of single spot correlation would result in extreme high and low coefficient values, which you can see here in this top image where the reds represent extreme negative and the green represent extreme positive correlation. You can sort of see this in the bottom chart where, yes, we have these points at the lower end and these points at the higher end, but we are not keeping those middle values in consideration here, which means that this method wouldn't properly be able to represent the data due to this limited sample size, as well as a lack of consideration for spatial variability. So my second method, which is what I used for the remainder of my internship, was this large-scale spatial correlation analysis using QGIS. QGIS is a tool I've never even heard of before coming into this internship, so it was definitely a lot of fun learning how to navigate it. But essentially what I did was correlate every single point of soil optics data with this vegetation indices maps in order to get more accurate results. So all those small yellow dots in the image on the top is a data point with all the macronutrients, micronutrients, and soil properties for that exact GPS location. The gray layer underneath is a vegetation index. In this case, it was GNDVI. This time around, the findings were indeed much more accurate, but it also revealed that there was relatively low to no correlation between the two data sets. You can see in this table chart below, the data is kind of spread all over the place. And this means that the analysis indicated that the changes in soil properties did not significantly correspond to the variations in vegetation health. So in conclusion, while I wasn't able to find a strong relationship between the two datasets, this isn't necessarily a bad thing. In the same way NDVI and NDRE can be used to supplement each other's weaknesses, we can do the same with soil optics and all the different vegetation indices we have access to. As soil optics has proved to have strong correlations with the truth values with a bunch of nutrients such as calcium and magnesium, which is still useful for the growers to know. Why wasn't there a strong correlation? We believe that there are a lot of external factors at play here that just can't be represented through just these two mapping tools themselves, such as nutrient uptake, soil moisture, and water intake. Now, if I was to continue on this project in the future, I would like to try a third method, where I would divide the smart orchard into localized regions based on factors such as soil type. Then, I would perform correlation analysis on each localized region independently. That way we would have less variability on at least one of the axes. And that's it for my project. Thank you.